In this video, we're going to look at how to prepare alkanes and also the physical properties of alkanes. So let's begin with the methods of preparation of alkanes. The first one is catalytic reduction of unsaturated hydrocarbons. Now, we can do this in the presence of catalysts like nickel. So if we have, for example, ethene and we now add hydrogen in the presence of nickel, we can also use palladium or even platinum. So we're going to have ethane because the bonds will be broken. The hydrogen will take the bonds. So we'll have ethane from this. The next method we have is hydrolysis of Grignard reagents. Now this is Grignard reagents. This stands for an alkyl group, magnesium, and then any halogen. If we add water to it, hydrolysis means splitting something or breaking down something using water. On this side, R will split, become negative, then MgX becomes positive. Then on this other water will give us hydrogen ion and hydroxide ion. Now, if they add, positive goes to negative. So this and this gives us ROH, which is an alkane. Then this other side will merge with this side, giving us an actual reaction on this is, let's see, for example, if we have C2H5, let's use bromine, for example. If you add water to it, it will split. This will split. One hydrogen, that's hydrogen ion, will go here to give us C2H6. Meanwhile, this will add with the OH that is left off there, which will give us MgBrOH. Another way we can produce alkane is by reduction of alkyl halides. Now, alkyl halides can be reduced to alkanes in several ways. One of them is by dissolving metals in a suitable solvent. An example is zinc copper couple in ethanol. The reaction mechanism follows the path of electron transfer from the metal to the substrate, followed by addition of protons from the solvent. What we mean by that is, for example, if we have this plus zinc alkyl halide, so it will split, we'll have R minus plus X minus, then we'll now have zinc 2 plus. Now the R minus plus C2H5 OH gives us ROH, which is an alkane, then plus we have O minus C2H5. So you need to remember, whenever a metal loses an electron, it becomes positively charged. So the RO minus being dissolved in ethanol now gives us an alkane. The next one is decaposilation of sodium salt of carboxylic acid. Now, when we heat the sodium salt of carboxylic acid with sodium hydroxide in the presence of calcium oxide, we'll get an alkane. What we mean by that is, if we have COONA plus sodium hydroxide and we heat it in the presence of calcium oxide, we're going to get an alkane, and then we'll get sodium carbonate, Another one we have is what we call Ward's reaction. Now, Ward's reaction is actually a method of preparing alkane by treating a solution of alkyl halide with sodium. The alkyl halide we mean is especially bromide or iodide. Now, if we have this, what we're going to get is a real reaction. Example is if we have, okay, let's use this. Now we have sodium. We're going to have 10, we're going to have 22, then so this is what we're going to have. Two alkyl halides with different lengths of alkyl chain could also be used, which is we have okay, let's just put it as prime just to show there's different prime, arrow prime difference. This and this, they are different. You can have use prime to show they are different. This is an alkane to show that you can still get an alkane. So the next thing we look at is the physical properties of alkane. The first one, their state. Methane, that is C1, to butane, that is C4. They are colorless gases at room temperature. The string chain from pentane, C5, to C17, thereabouts, are liquids. While those of them, higher molecular weights, they are all solid from C18 and above are solids. Now, their boiling points. For unbranched alkanes, the boiling point increases regularly the more the carbon atoms increase in the compound. For their melting point, it also increases as the number of carbon atoms increases, just like in the case of boiling point. For the viscosity, their viscosity, it increases also as the number of carbon atoms increases. The solubility, alkanes are virtually insoluble in water, although they are soluble in non-polar or slightly polar solvents. Example of polar solvents like benzene, diethyl ether, and so on. The solubility of alkanes diminishes with increase in molecular weight. Please, if you haven't subscribed to my channel, do well to click the subscribe button. Thank you.